Welcome back to Ghost Alpha Part 5. Today, we're going to focus on making Ghost Alpha playable to some degree. Every software project should begin with a clear objective. Before we write a single line of code, let's decide what those objectives should look like. Writing code is only part of the job. Professional developers also define how they're going to prove their code works. Our first objective will be to create the player, not just a character but the complete player experience. We'll build our first-person camera, first-person mesh, third-person mesh, and lay the foundation we'll continue building on throughout the series. Next, we'll configure Unreal's enhanced input system. Every interaction with our game starts here, so it's important to build this correctly from the beginning. A solid input architecture makes future features much easier to add. Once our player can receive input, it's time to make the Ghost Alpha move. Walking may seem like a simple feature, but it's our first real proof that the movement architecture we built is working as intended. With walking complete, we'll extend our movement system by adding sprinting. Rather than creating a completely separate system, we'll build our architecture we've already created, keeping our code clean and easy to maintain. We'll then introduce our first stance by adding crouching. This demonstrates why we separated movement from stance earlier in the series, and shows how good architecture makes new features straightforward to implement. Now, we'll start making Ghost Alpha feel like a real first-person shooter by attaching and simulating our first-person weapon. It's a small step visually, but it makes a huge difference to the overall experience. We'll also simulate our third-person weapon. Even though we're working in single player today, Ghost Alpha is being built as a multiplayer-ready framework, so both player representations are important from the very beginning. Finally, we'll set up switching between first and third person views. This allows us to verify both perspectives are working correctly. This also gives us confidence that our player setup is flexible enough to support gameplay features. This one feature has saved me hours of debugging when I have third person animation issues and weapon switching and weapon positioning in third person view. This objective is one of the most important lessons in today's video. In my experience, one of the biggest mistakes developers make isn't writing bad code, it's failing to define how they're going to prove that code works. Before we run Ghost Alpha, we're going to build a simple test script together. With our test scripts complete, we'll execute every test one at a time. Professional developers don't assume their software works, they verify it. If we discover a problem, we'll treat it as an opportunity to learn, fix, and continue. Before we create our player, there's one design decision I'd like to discuss first. One change I've made since the early lessons is how I organize shared types. Originally, I was trying to keep everything together in a single header file. But as Ghost Alpha grew, it quickly became cluttered. I've now moved to area-specific type files. Movement has its own type, weapons have their own, players have their own, and so on. This is a good example of something you'll see throughout this series. As a project grows, the architecture needs to evolve with it. Don't be afraid to refactor your code when you find a cleaner design. One thing I want you to take away from this is that software isn't carved in stone. As you gain experience, you'll discover better ways to organize your project. That's not a mistake, it's growth. By organizing our shared types by area, each system becomes easier to find, easier to maintain, and easier to extend in future lessons. Let's get back to our objectives. The first is create the player. Not just a character, but the complete player experience. By the end of this section, we'll have a player we can control, along with the foundations we'll continue building on throughout this Ghost Alpha series. When doing this, one of the easiest mistakes is to jump in and start creating gameplay features. Before we do that, we need a solid foundation. Every movement system, every weapon, every interaction we build from this point forward will depend upon the player we create today. As I previously mentioned, we have split out all the structs and enums into functional areas. This is the player types header file. In this file we have our player move states enum, our player stance states enum, our player game state enum, and something we'll be covering later, our view mode enum. Another one of the definition type files that we split out is the attachment types. In this we have attachment type, optic type, magazine type, muzzle type, under barrel type, stock type, flashlight type, and ammo type. And then we have two structs. The F weapon available attachment struct can be used as an array within the weapon that allows us to define which attachments are available for this weapon. The F weapon attachment is used to define the attachment, how it fits, and how it is defined using the attachment data class. The weapon type include file has enums for weapon type, ADS state condition, weapon state condition, weapon state, and ADS state. The state machine types include was originally from Ghost Alpha include and was covered extensively in part 4. Our movement types include has a struct for full damage rules and another struct for the movement settings. Our first person types include has a struct for first person view override, first person view result, first person weapon setup, and stance settings. Our attribute types include has a struct for attribute settings and stamina drain settings. As we go through this, you will notice a few types that aren't used in today's episode. That's by design. Ghost Alpha is built as a framework, so some of these systems are being introduced early and come into play as we expand the project throughout the series. Now we've got through them types, let's get back to our objectives, which is create the player. Let's walk through the player base header file changes. These are the changes that I've made between part 4 and part 5 code. I've also removed part 4 code that we used to test the stance state machine. You'll notice we've added pieces needed for both first person and third person views here. I'm not going to walk through the switching logic yet, that deserves its own objective, because switching views is not just code change, it's something we need to build, show and verify properly. These are the Unreal Engine components that we're adding for the first person. We have a pivot, a camera and the arms mesh. The first person pivot allows us to position the camera and the arms where we need them. First person camera is attached to the pivot. And then we have the first person arms. I like to have a separate arms and weapon mesh for all weapons and characters. Now for the third person components. The first one is the spring arm, which is pretty typical in a third person view. Then we have the third person camera, and then I have an additional skeletal mesh, which is the first person legs mesh. I have this so that when you are in first person and you look down, when you're walking, you can see your legs and feet. I also added some additional functions to initialize the character, pick up the character and apply its data, initialize the view mode, which we'll talk about again later, initialize state machines, and initialize movement. I also have a function to apply stance settings. We now have all the declarations for the manipulation of the inputs. So we have the apply first person pitch, set first person view, set third person view, toggle view mode, request standing, request crouching, request prone, request sliding, start fire, stop fire, start ADS, stop ADS, reload weapon, request sprinting, request walking, and request idle. Not all of these functions will be implemented currently. Then we have some helper functions so we can get the move state, get the stand state, and get the current view mode. Then we have all the stand state callbacks. For each stand state we have a begin, update, and exit. These were covered extensively in part 4. And finally we have the move state callbacks. Again, for each state we have on begin, on update, and on exit. We did change the include to include the player types, and we added some additional forward declarations. For the player base, CPP, we've added some additional includes. In the player base constructor, we're initializing and attaching all the components required for first person and third person. Now, initialize the component, initialize the state machines, and start adding the states. Firstly, move states, then stand states, and finally all the game states. In the begin play, we initialize the character, initialize state machines, initialize the view mode, and we set the initial stance to standing. Initialize character function, then we have the apply character data function. The initialize state machines initializes all state machine components. Initialize movement function currently is empty. The apply stance settings is used to apply any settings required for the specific stance state. Now we have all the function body for all the requesting specific states. This is what the set first person view body looks like. Then we have the set third person view function body. Now we have the state request functions. These are the function bodies for the stance callback functions. Now the function bodies for the movement state callback functions. Before we jump into the implementation, let's take a quick look at what's included in the Part 5 codebase. On the code side, we've added the updated player base, a dedicated movement component, new movement types, character data, and our first person setup. On the content side, I've also included a new test level, the character and weapon meshes, along with the animation assets we'll be using throughout this episode. With everything in place, let's start looking at the player base. As you'll see, all the components are already defined and attached accordingly. I've positioned the cameras and have also added my FPS weapon just for the demonstration purposes. You will also see that there is a third person weapon included in here. We will cover these a little bit later. So this pretty much completes our create player objective. Our next objective is to configure the input. We will start by reviewing the movement component. As previously discussed, the movement component should be responsible for all player movement. Any movement requests are passed into the movement component and it decides whether it can move, if it should move, and how it moves. Again, this keeps that functionality all centralized into its own component. Any movement requests are passed into the movement component and it decides whether it can move, if it should move, and how it moves. Again, this keeps that functionality all centralized into its own component. In the begin play, we get the owning character and we set walking. Then the initialize function basically gets the movement settings. Now we have the function bodies for set walking, set sprinting, and set crouching, set prone, and set sliding. These all call apply maximum walk speed and passes in the struct that defines that speed. This is the function for apply max walk speed, which receives the speed. It then gets the character movement component for Unreal, and it applies the maximum walk speed to the value that was passed in. Next is our player controller. We created a custom player controller to handle all our input from the player. This is the definition for all the input actions and the input mapping context. We override begin play and setup input component, and we also have functions to control all the actions we want within our game and a reference to the player base. In the begin play, we set the mapping context for the local player controller. In the setup input component, which is an overridden function from the base class, we basically bind all the functions we want to call: move and look, jump and sprint, crouch and fire, ADS and reload. We have a helper to get the controlled player, toggle view, toggle crouch and start weapon fire, and then stop weapon fire. The move function calls the appropriate state for that move request. Look function uses the add input for pitch and yaw, start jump, start sprint, stop sprint, start ADS, stop ADS, and reload weapon. All the input actions have been defined in the base code, as is the input mapping context with all the input actions assigned accordingly. Open the Blueprint BP player controller from the provided base code for part 5, and you will see all the mappings defined, including the mapping context and the input actions. That completes the configuration for the input. Our next objective is to walk. When a move input key is pressed, the bound function move is called. This goes through and does the move input, but then it also checks to see if the input values are 0. If the input values are near 0, it will go idle. If not, then it will call the player request walking. In the player class, we then set the move state to walking. This move state change will call the bound function for walking. It will initially call the onBegin walking. This calls the movement component set walking. As we already discussed, the movement component is central to all movement, and the set walking is no exception. It will now apply max walk speed based upon the actual walk speed set in the movement settings. The apply max walk speed, this sets the max walk speed in the standard Unreal Engine movement component. That completes our walk objective. Now let's discuss sprinting. Sprinting is basically the exact same as walking, with the one exception on the speeds we're setting. When the input key is pressed for start sprinting, it calls the start sprint function, then calls the request sprinting function within the player base class. This function checks that the current stance is okay for sprinting. If it is, then it will set the current move state to be sprinting. Now the onBegin sprinting from the callback will call the movement component set sprinting. This set sprinting function will call the apply max walk speed and set it to the sprint speed from the movement settings, just like the walk speed. And finally, just like with the walking, we call the apply max walk speed, which sets the walk speed to, this time, the sprint speed. So that checks off sprint. Now let's move to the next objective, crouching. When the input button is pressed for crouching, the bound function toggle crouch runs. This then calls the player base class function request crouching. The request crouching function now decides if it's going to be standing. So if it's already crouching, it will go standing. Otherwise, it will set the stand state to crouching. This will now call the onBegin crouching callback function. The first thing this does is apply the stance settings. The apply stance settings passes in this current stance state. It then reads through the settings on the character to see what the settings should be for this stance for this character. If it doesn't find anything, it will return without doing anything. Once it gets the stance settings for this character, it will then assign the radius and the height to the capsule. It will set the transforms for the mesh, and it will also set the transforms for the third person legs mesh and the first person pivot. This is our GA first person types, which is the include that has in the stance settings. This is used as an array in the character data class for each stance. In this struct, for each stance we can change the half height, radius for the capsule, the third person mesh transform, the third person legs transform, and where the first person pivot is set for that character. And that completes the crouching objective. Now on to the FPS first person simulation. I added this in part 5 so that you can see the simulation of how the FPS weapon is going to look in game. To simulate this, I added a skeletal mesh underneath the arms mesh for the first person. Ultimately, this will not be used. And then in the player, I just added my arms and my weapon mesh to that skeletal component. And that completes the FPS weapon. Now, we need to talk about third person weapon. This third person weapon is really only there to add shadows and allow you to see the weapon when you're in third person view. Later on, we will be attaching the third person weapon to the third person mesh socket. This will allow us to swap weapons during animation when switching. Okay, so now we're simulating the third person weapon. Let's go on to switching between FPS and third person. This ability to be able to switch between FPS and third person is an amazing debugging tool. It helps you to make sure that your weapons are positioned correctly, that all your third person animation looks good and is in sync with your first person animation. Also, it really allows you to be able to play in third person mode if you want to. This starts off with the player input. When the player presses the key assigned to switch view, it calls the bound toggle view function. This function in turn calls the player toggle view mode. This function now checks our current view mode, and if we're currently in first person, it calls set third person view, and if it's in third person, then it calls the set first person view. Set first person view initially sets the current view mode to first person. It then sets the first person camera active, and it sets the third person camera not active. It hides the third person mesh, and it sets it to cast shadows when hidden so that you see the shadows of the player in first person mode. The next piece of code, which is the third person weapon mesh, is temporary, but this basically does the same thing. It hides it so the player can't see it, but it still allows casting of shadows. Now it makes the first person arms visible and makes sure that it does not cast shadows. You never want the first person meshes to cast shadows. Now for the first person legs mesh, we want to have them visible and we want to make sure that they don't cast any shadows. And now we will make the first person weapon mesh visible, and we will make sure again it doesn't cast shadows. One thing you need to be aware of, this code is temporary just for the simulation of the first person weapon. Now let's walk through the set third person view function. The first thing this does is sets the current view to third person. Now it makes the first person camera inactive and it makes the third person camera active. It then makes the third person mesh visible and makes sure that it casts shadows. The third person weapon mesh is now set visible and also to cast shadows. The first person weapon is set not to be visible, and the first person legs are also hidden. And the last part of this function is it hides our first person mesh, which again is temporary. That completes our switch FPS to third-person objective. Now, let's talk about building test scripts. As I said previously, test scripts are critical. You need to make sure that you document what you want to test, and so that you can ensure that you've tested every scenario and you don't miss anything. When building a test script for new development, typically what you do is you list the functions that you've introduced. In this case, we have introduced keyboard, moving, mouse, look, crouching, sprinting, and switch view. So let's add each of these test requirements into our test script. To test the mouse functionality, we're going to do a look around, which should have the camera rotating smoothly. Our input keys for move, we need to test move forward, move backwards, move left, and move right. We introduced a sprint function, so basically we want to make sure that the player moves faster when sprint is pressed. We have a crouch function, so we want to make sure that the player crouches when that's pressed and also stands when the stand key is pressed. And finally, we added the switch FPS to third person, so we need to check that that works too. Okay, so we have our test script built. So let's go ahead and actually run each of them tests to make sure that everything works as expected. Let's check the look around functionality works. Now, let's make sure that the player can move forward and move backwards, move left and move right. For sprinting, let's check the player moves faster when we press the sprint key and slows down when we release it. For crouching, let's make sure that the player crouches. This test level has a reference point that tells us that our height changes. Plus, one of the good things about being able to switch between FPS third person, that helps us to see that he's actually crouching. Finally, just do a final check on the switch FPS to third person and make sure that the view changes. Our test script fully passed, so that I call job done. Today we covered input, movement, animation, and testing. Good architecture always makes gameplay easier. So today we finally have a player that we can move through the world. More importantly, we've done it without stuffing everything into one massive character class. Every system has a single responsibility, which means adding features later becomes much easier. In the next lesson, we'll continue expanding the gameplay system and keep building on the same architecture. If you're enjoying building Ghost Alpha with me, consider subscribing, and as always, let's build something amazing together.